Dear participants, myself Ajai Singh. In this presentation, I am going to talk about what and why of the data analysis. After data collection, once we are having the data, most of the time we are wondering that what to do with the data. With the help of the data screening, we can reach to a conclusion that what are the characteristics of our data and what type of the data analysis we can do with the data. The purpose of the data screening is to first to identify whether the data has been entered correctly or not. It means that key what can happen in the many cases is that in place of a particular number, we have entered a different number. For example, if we are having the data range of 1, 2, 3, 4, 5, in place of 1, 2, 3, 4, 5, we have entered the value like 15 or 17 or 21. In that case, we can identify the incorrectly entered the data. The another part which is concerned with the data screening is to identify the missing values. Many times what happens is that while entering the data, many times we are skipping the boxes, and because of some error or because of some other issues, we are having the different missing values in the boxes. With the help of the data screening, we can identify the missing values, and we can also take a decision what can do with that. The another purpose of the data screening is to identify the outliers and how we can handle the outliers. Outliers are basically the extreme values within a particular univariate or the multivariate scale. The another part of which is associated with the data screening is key the issue of the normality. With the help of the data screening, we can also identify key our data is normally distributed or not. And if data is normally distributed, we can go for the different type of the data analysis or the statistics. And if our data is not normally distributed, in that case, we can go for the non-parametric type of the data analysis. So one by one, we are going to discuss about the different types of the objectives, how we can handle the process of the data screening. The first part here we are going to discuss is about the incorrect data. Incorrect data means the data which was not originally responded by the respondent, but it has been incorrectly entered into the data sheet. With the help of the SPSS, we can go to the analysis part, and with the help of the counting the frequencies, we can identify any incorrect value entered into the box. Here we are having an example how we can identify the incorrectly entered value. Incorrectly entered value means any value which is not the real response from the respondent, and because of the reason because of that reason we are again interested in knowing the original value given by the respondent. With the help of the frequency analysis, we can identify the incorrectly entered value in the box. The another purpose which is associated with the data screening is to identify the missing data. Missing data is many times it is a it is a very big problem in the data analysis because missing values means the reduced sample size and the loss of the data. You conduct the research to measure the empirical reality, so missing values basically they thwart the purpose of the research. Missing values may also indicate the bias in the data. With the help of the SPSS, we can again, with the help of the frequencies, we can identify the number of the missing data, and with the help of the frequencies in the analysis part, we can identify the number of the missing data for the each variable, and we can again identify the particular subject who has not given response on the particular scale or on a particular variable. It can also help us in identifying that key who are the respondents who have not answered to the survey or the questionnaire in the serious manner. And if we are having so many missing responses from the same person, in that case we can exclude the data of that subject. The another issue which we also encounter in the data analysis or before the data analysis is the problem of the outlier. Outlier can be of the two types. It can be univariate or it can be multivariate as well. Outliers are basically the extreme values which are very much different, or they are basically very much deviated from the normal data. Because if we compare with the rest of the data, these values are the extreme values. The determination of the value as outlier is very much subjective, because in the different case we are having a different type of the benchmark for identifying an outlier. But in many cases SPSS takes, or the different data analysis software, they use basically the extreme values for identifying the outliers. Okay, then what is the purpose of identifying the outliers? Because outliers are basically, these are the extreme scores which are very much influencing the normality of the data. And normality is one of the major assumptions of the many statistical tests. And until unless our data is not qualifying the test of the normality, in that case, uh, we will have to go for the non-parametric type of the techniques, which many of the researchers don't prefer, because any data which is not normally distributed, basically their results or their findings cannot be generalized. The another part here is key, how we can identify the outliers. Okay, univariate outliers are basically the extreme values on a single variable. For example, if we are having the 10 survey questions in our study, then you would conduct basically 10 different univariate outliers analysis, one of each variable. Also, when you average the 10 questions together into a new composite variable, you can conduct the univariate outlier analysis on the new variable. Another way you would conduct univariate analysis is by looking at the individuals variables within different groups. It means any value which is extreme either for a composite group or for the individual group, we can go for the outlier type of the analysis for the different types of the subgroups as well. The second category of the outlier is the multivariate outlier. Multivariate outliers are the extreme combinations of the scores on two or the more variables. For example, if we are looking for the relationship between height and weight, then there may be a joint value that is extreme compared to the rest of the data, such as someone with extremely low height but high weight, or high weight but low height, and so forth. Then You look first for the univariate outliers, then proceed for the multivariate outliers. With the help of the descriptive statistics and the explore, we can go for the analysis of the outliers, and with the help of the different plots like the box plot and the stem and leaf plot, we can identify the outliers value for the univariate outlier as well as the multivariate outlier. Here we are having the example of the outlier analysis. Outlier analysis can be basically about how we can identify the extreme scores. Extreme scores means all the scores which are beyond a particular range, and after identifying them, we can uh, we can we can modify the extreme value into the next normal value, and after removing the outlier, we can again go for the normal distribution test of the data. Okay, then the extreme values and the box plot, they relate to each other. The box plot is basically a type of the graphical display of the data which shows the first median, which is the middle blank line. The median, sorry, number two is the middle 50% of the score, which is basically a region which has been shaded. Number three, the top and bottom 25% scores, which are the lines extending out of the shaded area, and the smallest and the largest scores, which are the horizontal lines at the top and the bottom of the box plot, and the outliers. The box plot shows both mild outliers as well as the extreme outliers. As as it is visible in this table and it is visible in this diagram that the extreme values has been identified by the software itself, and basically, and this plot box plot is showing the extreme value uh, of the one of the case number 42, and it has been identified in this diagram. With the help of this box plot, we can identify the extreme values are the outliers on the both end, on the higher end and the lower end as well. The another part which we are going to discuss here is the multivariate outliers. Multivariate outliers are basically analyzed when we are going for the analysis like the multiple regression analysis and the correlation type of the analysis. The multivariate outlier analysis is somehow complex, so I will discuss how to identify the multivariate outlier, okay, when we get to correlation and regression. If you want to reduce the influence of the outliers, we are having the four options. The first option is to delete the value. It means if we are having any extreme value, in that case what we can do is we can remove that value, or the another option which we are having is if we are having many extreme value for a particular variable, in that case we can go for the removal of the variable as well. If you feel that the question has been poorly constructed, or there are too many outliers in the variable and there is no need for the variable in the study, in that case we can simply delete the variable, and even we are having the option of transforming the value, and even after transformation we are unable to get the normal distribution of the data, in that case again we can go for the removal of the variable. The third option is to transform the value. We are having in a statistical package, we are having the option of transforming the value. But here in the case of the outliers, how we transform the value is very simple. What we do here is, if for example, if you have a 100-point scale and you have two outliers, 95 and 96, and the next highest, basically the non-outlier number is 89, then you could simply change the 95 and 96 to 89. And alternatively, if the two outliers were 5 and 6 and the next lowest value is the 11, in that case 5 and 6 would be changed to 11. These are the simple method of transforming the extreme value into the next normal value. The next option is to transform the variable. Transform here, what we do is instead of changing the individual outlier, we are now talking about transforming the entire variable. Transformation creates the normal distribution as described in the text section below the normality. Okay, since outliers are one cause of the non-normality, okay, in the next section we will be discussing about how we can transform the variable and reduce the influence of the outliers. After dealing with the outlier, we can rerun the outlier analysis to identify whether we are having the any new outlier emerging, or we are having the data which is outlier free. And once we are having the normal data, we can go for the different analysis. The another part which is very much important in the statistical analysis of the data is the issue of the normality. Normality is basically talking about the distribution of the data. And if the data is not normally distributed, it cannot qualify for the different type of the statistical analysis. Okay. Here I will be discussing about how we can determine the normality of the data. First, what is the normality? A normal distribution is a symmetrical bell-shaped curve defined by the two things, the mean and the variance. Second, why is the normality important? The central idea behind the statistical inference is that as the sample sizes increases, the distribution will be approximate normal. Most of the statistical tests rely upon the assumption that your data is normal. And if the data is normal, we can go for the parametric type of the statistics or the test. And if our data is not normally distributed, in that case, we can go for the non-parametric type of the tests. The parametric tests are basically the robust technique for the determination of the differences, or basically they are the robust technique for the determination of the relations. While if we compare the parametric test with the non-parametric test, the parametric tests are having the robust parameters with itself, while in the case of the non-parametric statistics, it is based on the, we can say, the nominal scale uh, type of the data and the ordinal scale type of the data. While in the case of the parametric statistics, it takes into account the interval type of the data for the further analysis. It means that we want, if we are interested in going for the higher level of the generalization, in that case we should focus more on the parametric type of the test. While talking about the normal distribution of the data, we can have a look of the distribution of the data with the help of the histogram. And if we look at the histogram with a normal curve superimposed, a histogram provides very useful graphical representation of the data. SPSS can also superimpose the conceptual normal distribution onto histogram of your data so that you can compare your data to the normal curve. The another very important values are the skewness or the kurtosis values. Skewness and kurtosis, basically they talk about skewness involves the symmetry of the distribution, while the kurtosis talks about the pickedness or the flatness of the curve. And any deviation from the normal distribution of data is a case of concern for any researcher or for any statistician, because any deviation from the normal distribution of the data, basically it requires us to either transform the data or it requires us to go for the alternate type of the statistics. Okay, but the next issue is, apart from the skewness kurtosis and the normal distribution curve, we are again having the different statistical tests uh, which can tell us whether our data is normally distributed or not, and it can be calculated with the help of the SPSS. Here the test is the Kolmogorov Smirnov test, which basically tells us about the normal distribution of the data. And if the value of the test is non-significant, it tells us that the distribution is normal. And if the value of the test is basically significant, in that case, the distribution is non-normal. Okay. But fourth, if your data is non-normal, what are the options to deal with the normal data? Okay, the first option is to leave your data non-normal and conduct the parametric tests that rely upon the assumptions of the normality. Just because your data are non-normal does not instantly invalidate the parametric tests. Normality is a matter of the degree, not a strict cutoff point. Slight deviation from the normality may render the parametric test only slightly inaccurate. The issue is the degree to which the data are non-normal. The second option is to leave your data non-normal and conduct the non-parametric test designed for the non-normal data. The third is to conduct the robust test. There is a basically emerging branch of the statistics called the robust test that are just as powerful as the parametric test but account for the non-normality of the data. And the fourth option is to transform the data. The transforming your data basically involves using mathematical formulas to modify the data into normality. It means if after following all these steps, we are not having the normally distributed data, in that case we can go for the different type of the transformation. It means if we are having this type of the distribution, 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 we are having here different types of the statistical transformation from for the different types of the deviated data. And with the help of these transformation, we can transform our data into a particular form, and after transforming the data we can again go for the test of the normality. And if our transformed data is normally distributed, in that case we can go for the parametric type of the statistics or the other statistics which are basically the eligible for the use of the normal distributed data. And If our data is not able to qualify the test of the normality, in that case we can go for again the non-parametric type of the statistics, which are not very much, we can say, robust in their application, and they are having their different statistical limitation. Okay, with the help of all these screening processes, we uh, we are able to know much more about our data, what are the characteristics of our data, and what type of the statistical analysis we can perform with the existing characteristics of the data. And with the help of this, we can go for the higher level of the statistics or the further analysis, like the comparison type of the test like t-test, ANOVA. We can go for the relationship type of the statistics like correlation, like regression. We can go for the higher level of the statistic for the analysis like the structure location modeling, factor analysis, and CFA. But all these statistics are basically ultimately based on key how we have collected the data and how we have screened our data and what is the characteristic of the data, so that we can move further for the higher level of the data analysis. In the last, I would like to thank all the participants for their patient hearing. Thank you very much.